Welcome to the high-tech classroom of Scientech Virtual Campus. The topic we are going to cover here is timer and counter of 8051 microcontroller. Discover the answers to the following questions in this lecture. What is a timer, and use of timer in 8051 microcontroller? Types of timer in 8051 microcontroller, and timer and counter programming. First, let's understand timer and counter. The 8051 microcontroller has two on-chip timers that can be used for timing duration or for counting external events. Both timer may be controlled, set, read, and configured individually. The 8051 has three general functions: keeping time, or calculating the time between two events, or for providing time delay between two executions. For counting an external event. It also used for generating baud rate, for serial communication. The 8051 has two timers, such as timer 0 and timer 1. Both the timer either used as a timer or for counter. We explain both one by one. Timer 0. It is a 16-bit register. Since 8051 has 8-bit architecture, so these register can accessed as two separate registers of low byte and high byte. The low byte register is called TL0, and high byte register is referred to as TH0. Figure shows the structure of timer 0, in which D0 to D7 represents TL0, and D8 to D15 represents TH0. Next is timer 1. Timer 1 is same as timer 0. It is also 16 bits wide, and its 16 bits register is split into 2 bytes, referred to as TL1, that is, timer 1 low byte, and TH1, for timer 1 higher byte. Next, we are going to discuss T-mod register, that is, timer mode register. Both timer 0 and timer 1 use this register to set the various timer operation modes. T-mod is an 8-bit register, in which the lower 4 bits are set aside for timer 0, and the upper 4 bits for timer 1. As we see in an animation, the lower 2 bits of both the timers are used to set the timer mode, and the upper 2 bits to specify the operation. Now we move towards the detailed description of each bit of T-mod register. The first 2 bits are M0 and M1. M0 and M1 are used to select the timer mode. As we see in an animation, there are 4 modes, namely mode 0 to mode 3. Generally mode 1 and mode 2 are used in the timer. We will explain all the modes one by one. First is mode 0. When the value of M0 and M1 is 0, then mode 0 is selected. It is a 13-bit timer mode. Mode 1. Mode 1 is a 16-bit timer mode. It is an important mode used in a timer. The value of M0 and M1 for this mode is 0 and 1 respectively. In these mode THX and TLX are cascaded, and there is no prescaler. Mode 2. It is an 8-bit auto-reload mode, therefore, it allows only values of 00 to FFH to be loaded into timer's register, TH. Mode 3. It is a split timer mode. This mode is not generally used. Next pin of T-mod register is CT. This bit in the T-mod register is used to decide whether the timer is used as a delay generation or an event counter. If CT is equal to 0, It is used as a timer for time delay generation. The clock source for the time delay is the crystal frequency of the 8051 microcontroller. If the CT is equal to 1, then it works as an event counter. Next pin is gate. We see in an animation both the timer have the gate bit. Every timer has a means of starting and stopping. Some timer do this by software, some by hardware, and some have both software and hardware controls. The timers in the 8051 have both. If 0 is set on this pin, then the start and stop bit are set by software. If gate is equal to 1, then this action is controlled by hardware. Above all, the configuration for timer 0, and it is same for timer 1. Next is T-con register. Figure shows the structure of timer control register. The timers are started by using instructions to set timer start bits TR0 and TR1, which are called timer run control bit. They can be cleared by clearing these bits. When a timer counts to its maximum value, it sets a flag TF0 or TF1. A register is used to control the timer or counter operation is called T-con. As we see in an animation, lower 4 bits of T-con for interrupt function, and upper 4 bits for timer operation. Now we are going to discuss the structure of T-con register. Table shows the structure and use of each pin. Pin 7 is TF1, that is, timer 1 overflow bit. This bit is set by microcontroller when timer 1 overflows. Pin 6, Tier 1. Timer 1 run control bit. When this bit is set, timer 1 turned on, and when this bit is clear, timer 1 is turned off. Next is pin 5, used for timer 0 overflow bit, is set by microcontroller when timer 0 overflows. Pin 4, TR0. Timer 0 run control bit. When this bit is set, timer 0 turned on, and when this bit is clear, timer 0 is turned off. It is same as pin 6, but timer 0, instead of timer 1. Next 4 pins are pin 3 to pin 0, which are used for interrupt. Detailed description of these 4 pins is in next lecture. As we discussed earlier, there are 4 modes used in the T-mod register, that is, from mode 0 to mode 3. But generally, only 2 modes are used, that is, mode 1 and mode 2. Now, we are going to discuss about timer mode 1 programming. As we know, every timer needs a clock pulse to tick. If C upon T is equal to 0, the crystal oscillator frequency is the source of the clock for the timer. This means that the size of the crystal frequency attached to the 8051 also decides the speed at which the 8051 timer ticks. Generally, we use 11.0592 MHz frequency oscillators. The frequency for timer is always 1/12. The frequency of the crystal attached to the 8051. As we see in an animation, crystal oscillator frequency is 11.0592 MHz, which is divided by 12. To generate a time delay, using the timer mode 1, following steps are taken. To clarify the steps, see it on an animation. T-mod equals 0x01. Load the T-mod value register, indicating which timer is to be used, and which timer mode is selected. In this we want to use timer 0 and mode 1. So first, let's understand how to find out the value, which we put in the T-mod register. As we see in an animation, the structure of T-mod register, in which lower 4 bits for timer 0, and upper 4 bits for timer 1. We don't want to use timer 1, so all the bits of timer 1 are 0. But in timer 0, we want to use mode 1. To select mode 1, value of M0 and M1 are 0 and 1 respectively. And the value of C upon T in gate is also 0. So finally, the value of T mod register is 000000001, that is, 0x01. Load TL and TH with initial count value. TL equals 0xF2, and TH equals 0xFF. In this animation, TL indicate the initial value from which timer 0 starts his count. The value of TL is any value between 0000H to FFFFH. And TH indicates the final value at which timer gets stop. TR0 equal 1, that is, timer 0 start. When the value of TR0 is 1, then timer 0 gets starts. And when the value of TR0 is 0, then timer gets stop. Now keep monitoring the timer flag, TF, to see if it raised. When TF becomes high, stops the timer. Now, we see in an animation. After applying a clock signal by crystal oscillator, TL starts his count from initial value, which is set, that is, F2, and counts up to final value, which is set into the TH register, that is, FF. When TL gets equal to the value of TH, overflow flag TF gets high, as we clearly see in an animation. Clear TF flag for next round. Now, we are going to write a program to generate a frequency of 100 kHz on pin 1 of port pages 0. The crystal oscillator frequency, which we used, is 22 MHz. We see the program on animation. Now, we discuss each step of program one by one. First is hash, include reg51.h. In this, hash is a syntax, and reg51.h is a library, in which some micro or predefined functions are stored. The function of this instruction is to include all the micro or predefined function for the program. Next is s-bit pin equal to p0-1. This is one of the way, which is used for defining a particular bit of a port. In this, s-bit means single bit, and it is mandatory to write. Pin is a keyword, and it is not compulsory to write on a program, or we can write any word on this place. We like to use pin 1 of port P0, so write P0-1. Next is void main. It is a main function by which execution of program gets start. Tmod equal to 0x10. It is used for select the timer and its mode of operation. We want to use timer 1 and mode 1, so the value of tmod is 0x10. Which is discussed in previous slide, to how to find out the value. Next is TL1. TL1 is equal to 0xF7. TL1 is a lower byte register of timer 1. In this we put a value 0xF7, means from F7 it starts counting. Next is TH1, it is equal to 0xFF. The value stored in TH1 is a final value, at which timer 1 counts. Next is TR1, it is equal to 1. When the value of TR1 is 1, timer 1 is start, and when the value is 0, timer 1 gets stop. While TF1 is equal to 0. It continues monitor the TF1 flag to become high. When the value of TL1 is reach up to the value of TH1, then TF1 gets high and jump to next instruction, as we see in an animation. Now a question arises in our mind is, how to find out the value, which we put on the TL1 and TH1, and also how to generate a 100 kHz frequency. For these we represent a simple calculation shown in an animation. As we know that timer clock frequency T is equal to 1 upon 12th of crystal oscillator frequency. We use 22 MHz frequency crystal oscillator. 22 MHz is divided by 12. By this, we got 1.833 MHz. We know that time period is inversely proportional to frequency. So by this, we got time period is equal to 0.546 microsecond. This is time period to execute an instruction when we use 22 MHz frequency oscillator. To generate the frequency of 100 kHz, required time period is equal to 1 upon 100 into 10 to the power 3, so we got 10 microsecond. But for generating square wave of 100 kHz, half of it for high and low portion each, so time period for both is 5 microsecond. Now, we calculate how much cycle is required to generate 100 kHz frequency. This is calculated by 5 microsecond divided by 0.546 microsecond. So by this, we got 9 cycles. So the number of counts required is 65536 minus 9, that is 65527, that is FFF7H. In this, 65536 is a decimal of FFFFH. If we put FFF7H value on TL1, then it counts up to FFFFH, that is, 9 counts. Next is TR1, is equal to 0, it indicates that timer 1 gets stop. Next instruction is for complement of the pin 1 of port 0. We do this, because whatever the last stage of pin 1, it either 1 or 0. We have to do complement of this, to generate square wave. Now we see in an animation, LED is glow. Next is clear timer flag, that is, TF1 is equal to 0. The loop is continued. Now, we discuss one more program, for toggle all the bits of port 0. We see the program in an animation. First is hash, include reg51.h, it is a header file. Void delay, defining main function. Void main, it is a main function, after that execution is start. While 1, it is used for looping purpose. If we want to do any process for infinite time, then we use while 1 keyword. Next is P0, it is equal to 0x55. After execution of this instruction, all the even pins of port P0 has high voltage. As we see in an animation, all the even pins LED of port P0 glows. Delay, calling the delay function. Now we see that, when we call the delay, cursor gets its position onto the void delay function. In this program, delay is required, because we want to blink or toggle the LEDs, so for these we required a time delay between on and off pulse. This delay is provided by timer. Now, we write a program for delay generation. Tmod equal to 0x01. It means we select timer 0 in mode 1. Next is TL0, equal to 0xF2, means lower bits of timer 0 is loaded with F2, and timer starts his count from this position. TH0 equal to 0xFF, as discussed earlier, it is final value at which timer counts. TR0 equal to 1, it is for starting the timer. While TF0 equal to 0, monitors TF0 to become high, and wait for particular time. Now animation shows the calculation for execution time of an instruction, with crystal oscillator frequency of 11.0592 MHz. After the calculation, we got clock period of 1.085 microsecond. so the number of count we got is 14. By this, delay is 15.19 microsecond. It means, when delay is call, the time duration between on and off pulse is 15.19 microsecond, but if we want to increase the time, then we should decrease the value of TL0. Next is TR0, equal to 0, it means timer 0 is turned off. TF0 equal to 0. Clear TF0 for next round. Next is P0 equal to 0 XAA, means after this instruction, the odd pins LED of port P0 glows, as we see in an animation. After that, once again delay is call, and processes get repeat forever. Now, we are going to discuss concept of timer mode 2 programming. As we discussed earlier, in T-mod register, there are 4 modes, in which third mode is 8-bit auto-reload mode. As we see in an animation, these mode has same structure as mode 1, but in these, flag register is automatic reloaded. To generate a timer delay, using the timer's mode 2, take the following steps. First is, load the T-mod value register, with the value 0x02, which indicates timer mode 2 is selected. Now, we see the structure of T-mod register. To select timer mode 2, the value of M1 and M0 must be 1 and 0 respectively. As we see in an animation, when we put these value we got 0x02. Next is, load the TH register, with the initial count value. In this, we put TH equals 0x48. After TH is loaded with the value, that is, 48, the 8051 gives a copy of it to TL. Then the timer must be started. It is done when value of TR0 is 1. Now keep monitoring the timer flag, TF, to see if it is raised. After the timer is started, it starts the count up by incrementing the TL register. It counts up until it reaches the limit of FFH or 255. When it rolls over from 255 to 0, it sets high the TF, that is, timer flag. As we see in an animation, the value of TH, that is, 48 is loaded into TL, and get incremented up to 255, then flag bit is set. After that, TF flag get automatic reloaded for next round. And TL is reloaded automatically, with the original value kept by the TH register, that is, 0x48. And again timer starts. And this process gets repeated. Next we are going to discuss is, counters of 8051 microcontroller. In last section, we used the timer or counter of 8051, to generate time delays. These timers can also be used as counters, for a counting event outside the 8051. When we use it as a timer, crystal oscillator is a source of frequency. But when it is used as a counter, then outside pulse is a source of frequency. Recall from the last section, that the C/T bit in the T-mod register, decides the source of the clock for the timer. If C/T equal to 0, the timer gets pulses from the crystal. When C/T equal to 1, the timer is used as a counter, and gets its pulses from outside the 8051. The highest frequency that could be measured by such a counter is 1/24 of crystal oscillator frequency. Now, we are going to write a program for counting an input pulse, or we can say that for measuring a frequency. We see a program in an animation. Now we are going to describe each step of program. First is hash, include reg51.h. As we all know, it is a header file. Next is SBIT input, equal to p3 4, unsigned integer I. Next is void main, it is a main function. Next is input equal to 1, it is for making port p3.4 as a input. Tmod equal to 0x15, by this value we define timer 1 as a timer, and timer 0 as a counter. TL0 equal to 0. TL0 is a lower byte of timer 0. Next is TH0 equal to 0, it is for clearing the higher byte of timer 0. TR0 equal to 1, it is for starting the counter. Next is for loop, that is, for I equal to 0, I is less than 15 and I++. Applying for generating the time delay of 1 second. In this loop it starts count from 0, and up to 15, and also incremented by 1. It starts count from 0, and counts up to 255 for a single value, then incremented by 1, and process gets repeat up to 15 values. Next is TL1 equal to 0, its load of value 0 in the lower byte of timer 1. Next is TH1 equal to 0, it is for load the value 0 in the higher byte of timer 1. TR1 equal to 1, it is for starting the timer 1, while TF1 equal to 0. By this instruction, it check the status of flag register, and also wait for TF0 to roll over, and this count will continue up to 255. Next is P0 equal to TL0, it means it sends a value of TL0 into port P0. By port P0 we can find out the frequency. Next is P2 equal to TH0, it means copy contents of TH0 into port P2. By this it count a pulse. Thank you.